We're in the Rocket City Regional here with Team 4028. This robot's been stellar on the field. They're showing off a 3L4 Coral Autonomous, a continuously rigged elevator, a combination claw. Joining me today is Natalie, Surya, Austin, and Gabe. All right, Natalie, go ahead and take me through a little bit of the overview of your robot and what you chose to do this season.
Yeah, so at the beginning of the season, we really wanted to prioritize that L4 Coral and scoring in the barge. And so everything we did really wanted to optimize those two. And so because of that, we chose to run a 3-stage continuous elevator and a dual end effector so that we could really make that an efficient process.
Yeah, so I can go into the elevator. To start off the season, looking at this challenge, we saw many ways to get up high, right? We have L4 in the barge, and we need to be able to get from the source, and those are two different heights. And so we were looking at different designs, like a pink arm, a lead screw arm, or just an elevator. And we ended up on choosing an elevator. And going into the elevator, there's two true options using cascading or continuous rigging. Both have their positives and negatives, but for our architecture Natalie talked about, a continuous elevator fit us best, primarily for the reason each stage moves up individually, which allows us to control our CG very well while driving. And that just goes back to overall gameplay, and if you want to be fast, you need to be able to be up high while moving.
So I do have a question. Notice, looking at your robot, it's very obviously a really compact form factor. So you went in, you chose to do an elevator. How many stages did you decide, and why did you decide to start with such a small elevator that can reach up high?
So we truly, everything was based off CG. We looked at a 2-stage elevator, and it would be roughly at our max height. But then we're like, okay, we made the decision to go with a belt in tube design, which is very compact and protected, going back to the idea that, let's say in this game there's algae rolling around and coral falling. We don't want our rigging exposed to the outside world. So all of it's contained in the inside. And so we decided to go with the 3-stage elevator in order to be really low to the ground for our CG. But when we go up high, we're still able to reach L4 and the barge. And then, so you can see like the belt's running dead center as well as in between each of the stages. And then going into the second big point of this elevator is the manufacturing and serviceability of it. There's a lot of very calculated holes in this elevator, like for example right here on this wall. Each stage has a set of specific holes to access every single screw on this elevator to be maintained. This just brings the lifespan of this elevator really high, and we can maintain it really well. And then all these bars are anodized and machined in shop, which means there are some tolerances we had to build in, and that was a really big thing of you need to be able to have this elevator move smoothly, but not loosely. Like when we're all the way up so high, we don't want it to wobble. So a lot of work was put in the precision cuts of these bars, as well as the designing of these bars. Next, I'll hand it off to Austin to talk about the pivot.
Yeah.
So our pivot is ultimately optimized for center of gravity. When this robot is all the way scoring up at L4, because our game piece mechanism is so light, as Natalie will soon get into, the majority of the weight is the powertrain and gears of our pivot. So what we ultimately decided to do was have the bottom powertrain of our pivot located a full 15 inches below our actual pivot point, such that when you're all the way up at L4, even though our pivot's approximately 8 pounds, half of that is 1.5 feet below the rest of the weight of our robot. Additionally, we decided to go for a 79-to-1 gear ratio on our pivot, and that is for a twofold reason. Number one, it's optimized such that when our game piece mechanism is spinning, it's still fast, but it's still controllable. Additionally, when we're in climb position, we wanted to make sure that when our pivot turned off and our chain is right here for our climber, the pivot and the game piece would not fall down and hit the chain and therefore negate our climb.
When you looked at designing your pivot, we can see that the coral end effector and the algae end effector are kind of moved relative to each other. So was that taken into consideration when you did your pivot design, or is that something that you considered later on?
So that's ultimately something that we considered later on. And for our game piece mechanism architecture overall, I'll hand it over to Natalie.
Yeah. So with our game piece architecture and this offset we did, Everything in game piece was to optimize our L4 coral scoring because that's what we really at the beginning of the year wanted to focus on. So when we are in the L4 position, it's optimized so that this algae is pointing down to help our CG and overall just keep it out of the way, which is what we really wanted to prioritize throughout the game piece. But
so I do have a question about your algae and coral manipulator. If you want to bring it back down to show. It looks like you're using a lot of 3D printing and space saving and material saving with this end effector. How did that play into your overall robot design in terms of maybe weight allocation and things of that nature?
Yeah, so especially for our coral mechanism, we decided to 3D print it to have quick, easy iteration. Because if with the 3D printer, we're able to overnight have a new mechanism. And so if there's ever any changes we want to make to it, if something breaks, it's a super easy swap. And the other thing with the printed material is it is super light so that we can help allocate our weight in different places. Also with the weight, our algae mechanism is all 16th inch material so that you're keeping a lot of your heavy stuff. You're not lifting a lot of heavy stuff up in the air, but we use these plates to help keep our strength. And so in the end, all of our game piece mechanisms are less than 10 pounds.
That's an awesome overall end effector and mechanism. Let's pass it over to Gabe to talk a little bit about software.
So our main priority this season for software was consistency. In this game, precision is key with half-inch tolerance on every single score. So our goal was to, yes, go as fast as we possibly could through all of our different functions, with the added constraint of being able to go to the exact same place and do the exact same thing every single time. So for us, that all really begins with our two swerve-mounted Limelight 4s located here and here. This is the hardware that makes up our vision system, and so we use both of these to keep track of where we are on the field. Contrary to what we did in previous years and what a lot of other teams are doing, which is using the built-in Megatag 2 library from Limelight, we decided to follow the advice of and take inspiration from a mechanical advantage post early in the season and work on a separate method which uses your distance from Megatag 2 along with your camera pitch and robot yaw to use trigonometry to calculate your pose on the field. What this allows us to do is eliminate the ambiguity from the solve PNP algorithm that the Limelights use to calculate your pose, which means that we can still get a very accurate position from a single tag, meaning
Awesome.
that we didn't have to add any extra Limelights.
Awesome.
Now, once we get this pose, the next thing we have to do is actually use it to get to the right place on the field. And how we do this is by keeping track of the closest reef side that we are nearest to, based on the April tag, and then applying an offset from that to find where we line up on the reef. So right here, I have an auton that we ran, a real auton from Quals 53 of our competition. And as you can see, it uses vision along with this reef pose that we're keeping track of, and a PID controller to line up to exactly where we need to go every single time. This has been one of the most consistent things we've made and has allowed us to score almost every single piece in auton, even if we get hit by, even if we, hit an algae driving over or utilize the wide bumpers and low CG of a robot to go faster despite relative vertical displacement of our wheels.
All right, that was a great overview of your software. We're gonna pass it back for one last couple revision comments.
So one big thing we're really proud of this year is the modularity of this entire robot. For our algae, our coral, and our elevator, they're very modular to be iterated on and improved upon throughout the season. So the algae and coral can slide off the Max Blind's shaft, but then the elevator, if you look down in the bottom here, there are these lugs that are directly implemented into the drivetrain, which hold the elevator with 8 bolts, and we're able to entirely remove the elevator just by lifting up and replace it with a brand new one. This just goes back to the point, like, we try to build robust designs, but let's say something does happen in match and we break, it's not the end of us. We can quickly swap out an entire subsystem, just leading to an overall well-designed robot.
All right, awesome. Well, that's going to be Team 4028 here at the Rocket City Regional. Good luck in the rest of your event, and we'll see you in the rest of the season. Thanks.